Hello, everybody. I presented last June the result of our studies to produce indicator of the presence of more than 300 languages in the internet. This time I will focus on the methodology which is behind. It is quite complex and quite long. I will try to go as fast as possible. And I suggest if you have a question, if you need to deepen the understanding of some point, to consult the paper which is written already. This is to give the appropriate credits to who founded or participated to the study. We are not newcomer in that field. We've been working since 1998 producing indicator of some language on the internet. We've been having difficulties after 2007, and in 2017, again, we were able to produce many indicators. We've been dedicating our attention since 2017 with our new method to the control of the bias. So it will be important part of the presentation. We are in a very strange situation. Many players were existing in the first period, 97, 2007, and in the following period, only two players in the field producing data, which were not from university, not from research, but marketing companies. The concept we developed in 2017 was from an idea of Daniel Prado, and it is that we use as much as possible and as different as possible figures, data about the internet to approximate the space of language, trying to get a very large scope of application and space on the internet. As the figures about language are extremely scarce, the originality of the method was to use country figures, which are much more common, and to transform country figures into language figures using weighting with demolinguistic data. Demolinguistic data mean how many speakers of each language in each countries. And then using typical statistical method and paying attention to bias, we were able to produce 4 macro indicators: power, gradient, productivity, and capacity, having split the source, what we call micro indicators, into 6 categories: internauts, people connected to the internet; contents in the web contents per language; usage, to application, to social networks, etc.; traffic to those applications, split per language; presence or absence of language in interface of main application or online translation program, which is a substitute to metrics about the technological support of language, which is not existing today for all language; and indexes, which is rating of countries in terms of information society progress, e-government, tax online, and so on, and that we have transformed into language with the same weighting method that I will present. In the version 3, after working hard on bias, we have evolved the concept slightly, and we say this is an indirect approximation of content because it is very complicated to get directly to contents. Based on observation on the field we have been doing since the beginning, and the beginning is many years ago, the content productivity, which is a ratio between content percentage over connected speakers percentage, which should be 1 if it is fair, above 1 if it is good, and below 1 if it is low. We have been checking that it was almost always between 0.5 for weak language and 2 for strong language like English. That suggests that there is some type of economic law linking for each language the demand, connected speakers, and the offer, contents and application. While connected speaker growth, newcomers on the internet in a specific language, more or less in the same proportion, contents in this language grow. This is a curve you can see on the right. What will determine, what will trigger the more or less modulation? The number of second language speakers. I am using the terminology L1 for mother tongue and L2 for second language. If you got many second language speakers in your language, you have more chance to have contents. The internet traffic generated in each country by speakers, which depends on tariff in the country, digital literacy, and culture. Subscription to social networks. Are there many people connected to Facebook, LinkedIn, and so on? The technological support that I have already spoke about. Information society progress. So if we are able to capture figures, data, characterizing each one of the factors which I have listed, we will be able to check the modulation and from that to deduce the contents for that language. This is a method. So we have the same different indicators, except that content is no more on the input, it is on the output. We produce three main indicators: contents per language, virtual presence per language, which is contents divided by speakers, content productivity by language, which is contents divided by connected speakers. So we do that by using technical of statistics and collecting as many sources as we can. As a matter of fact, we have almost 1,500 sources, 2 for internal, 42 for usage, more than 1,000 for traffic, 20 for interface, and 25 for index. I'm going to show you now the different sources, and I'm going to show you the bias management we have. For the internals, we got official source, which is ITU, International Telecommunication Unit, United Nations Organization, and which is completed by World Bank. So how we get the demo linguistic figure? From Ethnologue, which is probably the best, but not cheap, data available right now to have the distribution of speakers per country for L1 and L2, L1 plus L2. We do a weighting operation. This is the equation to get from those data the number of speakers connected per language. It is not so complicated that it looks. I will take an example. Let's take Venetian, the language which was born in Venice. There is 4 million speakers of Venetian in Brazil, 50,000 in Croatia, 3.8 million in Italy, and a little 2,500 in Mexico. This is the data from Ethnologue. Total 7.8 million Venetian speakers, L1 and L2. If you take the percentage of connected persons per country, we know that Brazil is 81%, Croatia 78, Italy 70, Mexico 72. So the equation is very easy. How we compute the 75.66% of Venetian connected to the internet, multiplying, it's a matrix product. We multiply the first column by the second column and we divide by the product. This is what we call the weighting operation, which is the base of the model. For usage, we got 36 social networks where we know the subscribers per country, and we deduce by weighting the subscriber per language. We got the next very good source for e-commerce, the T-index from Eminent, which is rating every country and every language in terms of e-commerce. For video streaming, we got 2 sources, Netflix subscriber per country and YouTube penetration per country. For open content, which is another group of usage, we got today only 1 source, the sum of OpenOffice download per country. And for infrastructure, we got very good data from the World Banks for all countries. fixed line, mobile lines, and bandwidths for the internet per country. From that, we can measure the usage. Obviously, not data we found cover all the 250 countries in the world. So what do? If we cannot leave zero if we don't have the value because it will give a wrong result. So we have to extrapolate. Where there is no data for a given country in the source, we extrapolate by prorating, another type of weighting, with connectivity figures. And sometimes we use prorating, another time we use the quartile method, depending on the data. For the traffic, we are able, thanks to tools which exist like Alexa.com and SimilarWeb, they give you give them the website name and they will tell you there is 60% of the traffic come from United States, 20% from France, 5% from Spain, and so on. So we are able, if we pick a good selection of websites, we are able to measure the traffic. And again, we complete missing data by extrapolation and we transform into language data by weighting. Interface or translation option, it is a very objective data. I show you here, for instance, Google translation, the language which are supported. You can go to Facebook and they will tell you the 72 languages which are supported. So we use 13 applications and 10 online translators, and we list the language which are supported, and from that we compute a percentage, and from that we weight so to have a world percentage for language. In terms of information society, you got on the right the list of the 27 sources we are using, which are coming from international organizations, NGOs, universities, access to advanced education, access to basic knowledge, government readiness for artificial intelligence, and so on. We got a very large set of data, and from that, and extrapolating again, we have, and weighting with demo linguistic data, we reach the weight in terms of language. From all that computation, which are quite complex, we are so able to say what is the percentage of each of the 329 languages we have selected in the internet, and the virtual presence for each one, and the content productivity. This is the type of result I have presented in Marseille in the LREC SIGULB meeting. You will see that the results we are obtaining are not 100% precise, obviously, because it is an indirect method. We estimate we are right in a confidence interval of minus 20%, between minus 20% or plus 20%. So if you list the data, you can see that Chinese and English are the first language on the contents with overall 20%, followed by Spanish with more or less 8%. Then you got Hindi, Russian, French, Portuguese, and Arabic with all between 3 and 4%. Then Japanese, German, Malay. If you want to know which are the languages which are the more connected to the internet, Norwegian, Danish, Swedish, Catalan, Japanese, Finnish, etc. If you want to know what are the languages with a higher content productivity, I was expecting English, but Japanese is getting just a bit over English. Chinese, German, Spanish, Italian, French. Same for virtual presence. You got the ratio for the top country, but we are able to give that result for 329 languages, the language which have more than 1 million L1 speakers. We are able also to gather the data by language family, and in this table, which is quite interesting, you will see that European language are representing 45% of the content, but Asian language are getting very close with 44.7, and African language are really late on the internet, and there is a big gap which is a consequence of the digital divide. You can see we are able also to provide results like what is the repartition of the English speaker connected to the internet? And surprise, after United States with 30%, you got India with 12% before United Kingdom and Germany and Nigeria before Canada. Interesting. Let's check now the bias and limitation of the method. We have been measuring the bias in a very subjective way, like a rating of a student between 0 and 20. 0 is terrible bias, you don't want to believe that, and 20 is no bias, almost no bias. From version 1 to version 3, we have been progressing from an average of 14 to 15, and now we are almost 18, which is a very good bias assessment. I'm going to show you the different bias for each of the indicator and for the method foundation and for the method for processing the second language. The method foundation, the weighting I show you for Venetian is based on a working assumption implicitly, which says all language in the same country have the same connected speaker rate to the internet. Is that true? No. The digital divide also exists within a country. But this is an assumption you have to do when you do this type of modeling to simplify the computation and to make it possible. So what is the implication of this bias? If we don't compare language within a country, no problem. If we avoid language population with very low number, where the bias can become really critical, not a big deal. We have to know that we are biasing positively immigration language in developed country. Immigrant in Spain, Arabic speaker in Spain probably have less connectivity than Spanish speakers. Catalan speaker in Spain may have more connectivity rates than Spanish speaker, but we cannot compare that. And reciprocally, French speaker in Africa are probably more educated and have a better economic level, and they are probably more connected than African language speakers. But we cannot play with that, so we accept the bias. It is what we call a workable bias. In version 1, we have no demo linguistic data for second speaker, for L2. So we were obliged to extrapolate results from L1 to L2. And that was a big bias, which was favoring English and French particularly, which are very important language in developing countries. Hopefully, when we bought the database from Ethnologue for version 2 into 2021, Ethnologue for the first time in the history offers demo linguistic data also for L2, which solves the issue. This is why you see the rating of the assessment of the bias getting from 13 to 19. Problem solved. Talking about L1 and L2, which is a very important matters. Following Ethnologue data, and you have to understand that when we take data from a database in 2021, it is probably collecting data of speaker per country from earlier years, 2020, 2018, 2019. But the data we use says that the world population, which is equal to the number of L1 speakers in the world, is 7.2 billion of persons. Now, if you talk L1 plus L2, we reach a very much higher number, which is 10 billion, which means that the level of multilingualism of humanity following Ethnologue source is today probably around 43%. 43% of people in the world are speaking more than one language. You have to know also that demo-linguistic data are not very precise matters, and there is a lot of difference depending on source, especially for English. If you take Ethnologue, it will say that there is 1.35 billion of English speaker L1 plus L2 in the world, 370 million L1 and 978 million L2. Wikipedia, which is another source, give 1.18, a lower number. Statista, which offers statistics, but we never know where they pick it because we have to pay to know that, it is 1.5 billion, a higher number. David Crystal, which is a famous researcher on language and linguistic on language, says that at one point of time in the future, he thinks that English speaker L1 plus L2 will reach 2 billion. But today we have used ethnologue data, but if you see different results in different studies, maybe it is because they have different sources for demolinguistic data. Important warning, because we have seen so many times this mistake in studies. You cannot compute, if you say you are focusing L1 plus L2, you cannot compute percentage on world population. You have to compute percentage on L1 plus L2 population, which is much higher than world population. If not, you are hiding a huge error in the rest of language that you are not listing, okay? Let's now check the bias management for each of the indicators. Internals, I told you we use ITU and World Bank, two official entities. We can trust them, and it is highly reliable. They use a common worldwide definition. They are checking sources which are serious sources like European Union. Very good level of bias management here, and it is important because this data is fundamental in the model. We are using it a lot for weighting, for extrapolation, for quartile, for many things. We are using the repetition of internodes per country that we transform in internode per language. So it's a key data of the model. Indexes. In V1, we have only 5 sources. In V2, we have probably almost covered all the possible sources, 25. So reliable university, organization. So we are very happy. We don't have a big bias here. Contents. In version 1 and version 2, contents was an input indicator with a very bad rating of 5, moving to 8. And we decided in version 3, it was impossible to get an unbiased data, so we will leave it from the model and we reshuffle the model in a different manner. I will explain. In the main source for content data is a wonderful source, is Wikimedia. Wikimedia, which includes Wikipedia, Wiktionary, Wikibook, Wikiquote, etc., is the most multilingual application in the internet with 329 linguistic versions. Coincidence, we got the same figure for our numbers, but it's just a coincidence. And on the top of being the best multilingual source, they have outstanding statistics for each thing. So it is really, it was a key source for our modeling. However, in spite of its real success in getting every day more global, it does suffer from an Occidental bias. And also, there are some anomalies which are due to some aggressive linguistic community policy for some language, which are not so important on the internet, but they are very important in Wikimedia. It is the case of Cebuano and Tagalog from Philippines and Malagasy. Malagasy have less than 10% connected speaker in the country, but the Malagasy people, and good for them, it's not a critical, at the contrary, they've done a very good job to be present on Wikipedia. But this is not very good for the type of study we are doing. So we got a problem. We tried to remove the bias in contents in 2 steps. First step, we discovered there were language translating Wikipedia article from other language, and after that, they were leaving them with no updates, not good. So how we could manage that? We cannot use the number of articles as the main indicator. So we use an equation, which is highlighted in yellow here. using a product of article, number of edits, number of editors, the depth, which is a very interesting data offered by Wikipedia, and we divide by the number of speakers on the square. This allows to have a fairer representation of language in Wikipedia. Then we weight the different sources we have. We have a very good source from the index for e-commerce. We got the Wikipedia formula, we give a 1. We got the number of books in Amazon per language, and the other Wikimedia. So we make this weighting, and we managed to go from 5 to 8. It was still quite biased. So we make the ultimate effort. The bias comes from the fact that there are other online encyclopedia per language. So let's do the job. Let's take all the online encyclopedia per language and merge that with Wikipedia figure to get a better result. We did that. We did that, and we conclude after, I will show you now, no way. There is no correlation between the presence in online encyclopedia and the presence in web content. Some languages have invested a lot, others are not interested. Look. On the right, you got the Wikipedia stats as of today. A total of 56 million articles, English first with 6 million, followed by Cebuano, German, Swedish, French, Dutch, Russian, Spanish, Italian. So you got the order of magnitude. 6 million is very good. Look now on the left with the effort we have made to check all the online encyclopedia. Chinese have, with Baidu Baike, 24 million articles. Baike have 18 million. We have not been able to find any data on Sogu Baike, probably it's the same, 20 million. So you got more Chinese articles in Chinese online encyclopedia than the whole Wikipedia. Now you got also some language like Korean, Italian, and Turkish. Turkish have 8 million articles in Exisosloop, which is more than English in Wikipedia. So some languages have invested, others not. We cannot use that. It was a huge effort, it was a lot of work, but at the end, the conclusion was we cannot use content as an indicator of input, so we scratch it from the list. Traffic management was a third important bias component of the model after content, consequence of the use of the tool like Alexa, which for version 1 was quite biased against Asian countries and Brazil. How do we know that? Because we compare traffic to social network with subscriber to social network per country, and we have to find some type of correlation, and it was not the case. Version 2 showed an enhancement in terms of Asian bias, but we discovered a bug. It looked like a bias against European country, but it was a bug. They were forgetting to give the main country in terms of traffic for European countries. So we had a problem. And we discovered also playing a lot, making a lot of exercise with different selection of websites, that the selection bias was huge. You cannot say that the list of 500 websites you have listed to make the traffic is not biased. You have to make a special effort to unbias that. That's what we did in version 3. I will not go through. I suggest if you're interested, you check on the papers we wrote. But we did really a very strong and serious effort to unbias the selection of websites. And this is why now we are trusting our result, and we give a 17 to the assessment. Interface is no bias, it is objective. You are or you are not present on the interface, so it's 19. Usage was the second more bias indicator after contents. Mainly the bias came from the social network selection we had. At the beginning it was less than 10. Facebook, LinkedIn, Reddit, Instagram, the main Occidental social networks? Well, there are many other social networks in Asia that we have to pay attention to. I am listing here some of the Chinese. So we decide to, as we did for the encyclopedia, to check all the social network on the world. And we make a limitation to make the work workable to 100 million subscribers. So this is a list. We check, we move from the green part, which is below, to the brown part, which is above, with a lot of social network from Asia and Russia and other parts. Important. We got data for Facebook, Instagram, LinkedIn, Twitter of subscriber per country. We do not have data of subscriber per country for Duban, Outlook, Klasniki, Discord, Line, Imo, Viber, and so on. So what do we do? We use traffic measurement and extrapolation to guess the number of subscribers per country, knowing the total. We know the total, but we don't know the repartition. So this is what we did. It was a very good improvement. We are now 16, but it is still to be improved because we are very short in source for open content, and we are very short in source for video streaming. Netflix and YouTube is not enough. There are other, again, other ASEAN application here. We should put some stat on Mock also, very important. I will not go through the modelization, just tell you it's a very large Excel file of 20 megabytes with 16 different sheets which are all correlated. Some hold the source and all have some type of computing to reach the final result. Quite a complex job. And not only is the processing complex, but you have also some pre-processing to do the job. Why? Well, you have Ethnologue give you a big matrix of 11,000 lines with ISO name of language name, country name, L1 speaker, L2 speaker. What we need is a matrix with countries and language and the speakers on the cross. Also, there is a concept of macro language. There are 29 macro language which are going to Arabic. There are 25 for Hmong, etc. 60 language have macro language. So we need, if we want to have results for Arabic, to merge Egyptian Arabic, Moroccan Arabic, etc., etc. 29. So it was a complex job done by program. And if you do that, you have to be very careful when you get source of data to do the same. For instance, we got the Serbo-Croatian as a macro language, which is 4 languages, Serbian, Croatian, Montenegrin, and sorry, I forgot the first one. So you have to be careful when you get source to merge that. Pre-processing and quite a big processing. Not all countries have data from ITU. Some very small islands do not. Some other islands have merged with the main country, like Guadeloupe or Martinique in France. Kosovo have data from ITU, but is not included in the log version we have, so we cannot manage it. So some pre-processing. I almost finished. Let's go now to talk about other source bias. I told you there were 2 main sources. Since 2004, Internet World Stat offers the 10 top internet language. Since 2011, W3Text offers the 35 top contents language and do the job every day. Every day they launch their algorithm and they get the data. These people have been alone as a source for many years, so many people have used them for their study and for their conclusion. If you draw good theorem from wrong axiomatic, you have a problem. And this is which may have happened to many people with language on the internet. I will show you why. If you compare our data with Internet World Stats, there is not too many difference. Some difference come from the demolinguistic source, which are probably different for them. Other difference come from the fact that they have computed their 10 language on the world population. So they got very high number, which is not fair because you have to compute on L1 plus L2 population. But the problem is serious with W3 Tech. They say that since 2011, English is 60% of the content. We have 20%. We've been evolving from 70% on the history progressively to 20%. They say that Chinese have only 1.4% of the content. We say they have 20%. They say that Hindi have only 0.1% of the content. We found 3%. I mean, there are huge difference. One, at least, of the two, us or W3 Tech, is totally wrong. What could be wrong with them? They are doing a very good job of technological survey on the web, measuring the language of all the language for programming language, JavaScript, and so on. But language, human language, is not a web technology. There is a factor they have forget, which is multilingualism. They are counting homepage from the 10 million websites the more visited. Let's forget the bias of selecting the top of the iceberg and focus multilingualism. They are counting homepage and not web page. So they measure the same website with 10,000 pages and website with one page. They count one language per homepage, per website. But many sites are not one language. They have many languages, like Facebook 70. Our observatory has 3 languages, sometimes 4. So forgetting multilingualism is making a huge mistake, and more because they are using an algorithm which is stand on English. So implicitly they say, oh, there is English in the homepage, it is an English site. The site may be in Spanish, but if there is one English word in the homepage, they say it's English. So huge mistake. They could fix this mistake not with a big deal. They could fix the mistake by trying to evaluate the number of web pages by sites and multiplying. They should check the language interface which exists and split the counting for each language. And in the case the homepage have only 2 languages, English and something else, give it to something else to avoid the mistake. If they do that, maybe they will have closer result to what we have found. Anyway, is it credible that between 2011 and today, when the internet in terms of language have been exploding, is it possible that English have stayed steady? It will mean that English will come close to the exponential growth. Come on, English grow, but not exponentially now. Is it possible that in 2011, 1/3 internautes was English speaker? Today it's 1/8. So they cannot have the same number of contents. If you take Chinese, Hindi, Arabic, Turkish, Bengali, Vietnamese, Urdu, Persian, and Marathi, it's almost 1/3 of the contents on the internet. How come Chinese plus Hindi, which represent together 1/3 of the internet, have only 1.5% of the contents? No way. Very important. We have checked many studies and all say the same. People on the internet, and especially for e-commerce, but not only, they use their mother tongue if it is available. In India, for instance, which is the second English-speaking country in the world, people do not use English, especially on the internet. They use Hindi, Bengali, their mother tongue. So, and I conclude with that, today, the multilingualism of the humanity is 43%. I suspect that the web multilingualism is higher than humanity because we humans are not able to do like Facebook having 75 languages. If we have 3, 4, 5, we are good. If we are 10, and some people do, you are very good. But 75 language, no. Thanks for your attention.